Okay, so we're looking at statistics and we're looking at a thing called discrete random variables. Okay, so a random variable, okay, oh, I've got the pen now. Okay, random variable is one whose value cannot be predicted, okay, but determined by the outcomes of an experiment. So don't be too worried, but that's what the definition is. Copy and come across. Okay, so random variables are expressed as capital letters, okay, and usually these are the last few letters of the alphabet, but their values, okay, so the variable is x, but their values are expressed as lowercase, okay, and when we look at some questions you'll understand what that means. Discrete, as distinct from continuous. So discrete random variables generally deal with a number or a size, and so they're things that can be counted, okay? Whereas a random variable that can take on any size, which is continuous, and these are usually things that can be measured, okay? So things that can be counted are discrete, and things that can be measured are continuous. And in this first series of videos, we're just going to do discrete, and we'll come back and do continuous in the last few videos of this unit. Okay, so copy that and come across. Okay, so for instance, here's an example of what's discrete and what's continuous. So we can count the number of goals, so it's discrete. We can look at shoe sizes, and they are discrete, like size 5.5, size 7, size 9.5. They come in numbers. You don't have a continuous array of shoe sizes. But if you measured someone's foot, that's continuous because you can measure it. Okay, you measure it and there's no exact number. Okay, the time taken to run 100 meters is continuous because you can't. It's something that you can measure. Okay, so there's some examples. Okay, so when dealing with random variables, we have to look at the probabilities associated with them. So here's this capital letter. So X represents the number of tails that you can get when you toss three coins. Or toss a coin 3 times. So this is lowercase x, and x is the number of tails, the event. So we can have no tails, 1 tail, 2 tails, and 3 tails. Now you can do the tree diagram or whatever, but there is one way of getting it, times a half to the power of a cubed, and so that answer is 1/8. There are 3 ways of getting 1 tail, and obviously you need 2 heads, and that equals 3/8. There are 3 ways of getting 2 tails, and then you need 1 head, and that's 3/8 again. And there's 1 way of getting 3 tails, and that's 1/8. And so those numbers add to 1. Okay, so that's an example of a probability distribution. Okay. So X was the event, the number of tails, and then lowercase x is 0 tails, 1 tail, 2 tails, and 3 tails. And the probabilities were 1/8, 3/8, 3/8, and 1/8. So copy that and come across. Okay, so all the probabilities must lie between 0 and 1. So like in that previous one, we had 1/8, 3/8, 3/8, 1/8 as an example, and all of them lie between 0 and 1, but the sum of the probabilities equals 1. Okay, so those two things, if either of those two things are not satisfied, then you do not have a discrete probability distribution. So both things have to occur. You have to have 0 to 1 for each event, and the sum of all the numbers has to add to 1. Copy and come across. So here's an example of who knows what the event is, and I got scores of x is -1, 0, 1, and 2. You can have negative numbers, but looking at the probabilities, when you add those numbers up, you get 1, but these two numbers here are both not in the range of 0 to 1. Okay, they've got to be between 0 and 1. So this particular, whatever this is not a discrete probability distribution. Okay, so have to add to 1, and each number has to be between 0 and 1. Okay, so both of those has to fit. So copy that and come across. And there's the first exercise, questions 1 to 7 in Maths Quest 12. Thanks, see you soon.